So here we're going to talk about conditional probability. This is the probability in an event occurring given, keyword given here, that another event has already occurred. Okay, so let's take a sample space S, and we're going to have an event A and an event B. And they overlap, meaning they could both happen at the same time. Right? So event A everything in red here, right? And event B, where it intersects with A, we're going to doubly highlight it in here. All right. So how this works, okay? The given reduces the sample size. Okay, reduces the sample. How about we just say that? It reduces the sample. We reduce the sample to what it's given, all right? So the probability that event B occurs given A happened, okay? So the probability B occurs given A occurred. Okay, that's how we say that. So you might say the probability of B given A. That might be the shorter way. The probability of B given A might be how somebody would read this statement right here. The probability of B given A. This is equal to, well, where's the probability? What are we restricting to? We're restricting to what's given. So my new sample space is what's given. That's A. So the only thing I can look at is A. Okay, everything else in the sample is gone now. It's just A that we care about. So the denominator now gets reduced to the probability of A. Okay, that's my new denominator. That's my new sample space. And then I want to know what's the probability of B given it's A. Well, where does B fall into the A category? It falls in right here in this region right there. So that is the probability of A and B where they overlap with each other. Okay? So what is this telling me? What is this telling me? The whole key for conditional probability is that we reduce the sample space to the given. Okay, to the given. So whatever it is that's given in our sample space, that's our new sample space. Okay, so whatever they say is given, that's the new sample space. Now, let's take an example. We've got 2 cards that are drawn without replacement from a 52 card deck. Okay, so you got a 52 card deck. Now let's think about 52 cards. So with deck of cards, what do you have? Well, you've got hearts, diamonds, you've got spades. Oh my goodness, spades. And then you've got the clubs, right? Sorry, don't judge me on that. Okay. Now, with each of these, there are 13 cards, right? There's 13, 13, 13, and 13. And it goes from 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Ace. Okay, so each suit has those cards in them. All right, so you're going to take 2 cards without replacement. So once you draw a card out of the deck, you don't put it back. So I want to find the probability that the second card will be a jack, given that the first card is a 7. So given is the new sample space. So this is the new sample space. What is the new sample space? Well, we find the probability that the second card is a jack given the first card was a 7. Since we're drawing without replacement, what does that tell me? That tells me when I pull a card out of the deck, so the 52 card deck, when I pull the 7 out, so pull out a 7, now what is my new sample space? The new sample space is a 51 card deck. Okay? And it has 1 less 7. So what's the probability that you draw out a jack? Okay, that's the second card, given you drew a 7. Okay? So this is equal to what? It's equal to, well, how many jacks are there? What's the probability of drawing a jack? Well, there's a jack of hearts, there's a jack of clubs and spades and diamonds, right? So there's 4 jacks total, because we just pulled out a 7, we didn't pull out a jack, but out of 51 cards total. All right, so the probability of that second card being a jack is 4 out of 51. Why is it 4 out of 51 and not 4 out of 52? Because when we pulled the 7 out, there were only 51 cards left. My new sample space is what's given. That's the 51 cards. Okay? So this is my answer right here. Right? Look, you think about it, it's like, what's the probability you go to the park? Okay? So the probability that you're going to go to the park. Right? Now, maybe the probability to go into the park is like, I don't know, a 10% chance, right? Maybe it's a 10% chance. But what is the probability of going to the park given that it's raining? Given that it's raining. Well, if it's raining, I probably don't want to go to the park. But the thing is, when we restrict the new sample space to only the times where it's raining, that restricts it to not be times when it's not raining, okay? So that chance of going to the park, if you don't like to get rained on, now maybe it's like a 1% chance we're going to go to the park if it's raining, which I don't even know why you go to the park when it's raining, but regardless, you're limiting the days down now instead of any day that you could go to the park to only days where it's raining that you would go to the park. So you're restricting your sample space to what's given. That's the idea for conditional probability. So here's a conditional probability where we have a table. And very common, you'll see a table. So here's the question. Have you ever been offended? So first thing we're going to do is we're just going to break it down to yes or no. So males, 620 people said that they had been offended. And 530 females said that they'd been offended. So that was 1,150 people that said that they had been offended. Okay? Now, of the people that said that they weren't offended, 550 said that they weren't, that were males. 580 said that there weren't, that they were females. And so that's a total of 1,130. Now, the question might be, how many people total did they ask? Well, if 1,150 said yes and 1,130 said no, then that means that there were, add those together, you get 2,280 total people that they went out and asked, have you been offended? Well, what about males? Total, if you say all the people that said yes and all the people that said no, added those together, you get 1,170. And if you add 530 and 580 together, you're going to get 1110, okay? And so that's how you get the totals there, all right? So here's the question. Find the probability a person was male. What's the probability that you're male given that you were offended, okay? So the probability that you're a male given that you're offended, okay? So you see how I wrote that. Now, remember, guys, offended is the new sample space. So the people who were offended is my new sample space. People who were offended answered the question as a yes. So this is the only thing that I look at are the offended people, okay? So I don't look at anybody else, just the offended people, all right? So what's the probability that you're male given that you're offended? So the males, there's 620 of those. Out of how many total? 1150, okay? So that, my friends, is your answer, which is roughly 0.539 if you were asked to do decimal to 3 places, okay? Now, same problem, but instead we're going to use blue here for this one. It says, what's the probability that they were offended? The probability that you're offended given that you're female. So I'm going to use F for female, okay? So the new sample space now, what is the new sample space? It's always what comes after the given. So what comes after the given is the fact that we're female. So who do we look at from now on? The only people that we're going to look at are the females. So I'll look at the females to be my new sample space. And then who are the people that were offended? The people that were offended are the ones that said yes. So that's the 530. Okay, 530 over what? How many total females were there? 1110. Okay, and if you do that in decimal form, it should be like 0.477 approximately. Okay, so that's the idea for conditional probability. We reduce the sample. It was reduced. Look, guys, the original sample went out and asked 2,280 people. But if I reduce it to given they were female, then I only care about the 1,110 people that were female. I'm reducing it to just the ladies here, okay? That's the idea of conditional probability.